can hear you.
We can hear you.
Okay, guys, excuse me, as I just got through eating a bunch of onion rings and choking on them. So everything's set up now. Everything's back in place with regards to my capabilities to give you guys videos, SSH into my Pi. So we're back on track now, just in time for us to get ready to continue working on our RASM 3. We do have a quiz that I was trying to get up, but I wasn't able until I got my internet and everything straightened out over the weekend. It took me almost nearly 2 weeks, but everything's set up pretty good now. Okay, so our focus, our schedule is going to be on Wednesday. The quiz that I wanted to have up for you guys we'll be taking that in class on Wednesday. And in that quiz, we're going to be doing things, as I mentioned before, questions about AAPCS. Which registers do you pass parameters in? Which registers are the local registers that are, that you use to do your local variables inside your routine and function? Some stack problems. As you guys know, there were some homework assignments you guys been working on to find out how many times can you, in essence, how many times can you do a recursive call before you blow up your stack. And that was an assignment that we had for the factorial problem that's been, I think that was due last week. Okay, so those assignments are in. And today, like I said, what I want to do is I want to focus on RASM 3. And of course, once we go over our quiz on Wednesday, remember in class, you'll have 45 minutes. Make sure you're here on time, guys. It'll open up. It'll be a proctorial quiz, but you're going to need to do it in class so that we have time to go over the answers and get you guys ready for your second exam. Okay. So again, so to reiterate, getting you ready for your midterm, it's next week. The last quiz is on Wednesday in class, proctorial. You'll do it during the first 45 minutes of class, and then we'll go over it, and then we'll do a review. Okay. Now, what I want to do today is, this is the first time my Pi has even been turned on for probably going on 2.5 weeks now. So you're probably well ahead of me on any of your assignments that you've done for RASM 2 or 3. But what I want to do is, in the time that I have, right, is I want to go over RASM 3. And I'll pick, I don't know how much time I have, but I'll pick maybe the first 1 or 2 problems to kind of work them with you in class. Make sure everybody knows, first of all, you guys have your partners. Okay. I'm going to check here in a minute, and I'm going to see if you guys have your partners allocated. Okay. Those guys in the background are really good at holding still. Oh yeah. Yeah, they're mimes. Those guys are mimes. But anyways, I want to make sure, folks, make sure that you're in Canvas right now. If you haven't done so, you need to do it now, right? Because I don't want to hear it when you're having problems if you don't have a partner. Okay. And yeah, so today is going to be mostly live coding and RASM 3. Okay. Does anybody have any questions for me in regards to the material we've studied so far? Has anybody been struggling with malloking memory and freeing that memory up? Has anybody had any issues? I know that we solved that last week, right? Or I guess it was last week. We solved it a week before. Okay. All right. Well, since everyone's fairly quiet, and I will be taking attendance today at some point. Okay, so let's see, where are we? And of course, I don't have my glasses with me today, so I'm going to blow everything up really large. Let's see here. We want to go to RASM 3. Now, I did update the shortlist document. I haven't updated the massive document yet, so let's go ahead and take a look at this. Actually, let's see. Let's go Word. Okay, so we already have our string length function. We built that a long time ago. And the string equals function, that is the same thing as our string compare. But let's have a look and see where we're at here. Let me get rid of this. I don't want to save this. This is a recovered. I don't want to save it. I want it to cancel. So get all this out of the way. I want to auto save. And this actually, so folks, I want you to disregard these 15 lines here, okay? Because there may be some conflicting instructions here. The actual instructions for this are on the assignment. So when I edit this document now, let's just go ahead and roll in here and delete those. We update this. And let's have a look before I jump over to the assignment. Let's see how you guys are doing on the assignments. So we've got, see, 2, 4, 6, 8, 10, 11, 12. So about 12 of you guys. I think we have about 17 students in the class. So some folks are probably just beyond them at this point. Okay, so it looks like most everybody has signed up for a group, which is good. The ones, so the two people that are by themselves, is that by choice? Are you? I know that there are two people on there that that are in the groups that don't have group members.
Yeah.
I just joined one. I'm waiting for someone to join my group.
Okay, so if nobody joins his group, we got to decide this today, right? Because this assignment's due in how many days?
Like 2 weeks.
In 2 weeks. All right, so let's get this figured out now because I don't want you in the lurch. Let's see, the people we have in the class are, I have 1, 2, 3, 4, 5, 6, 7. Make sure I don't count myself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Actually, you know what's easier if I just come over here and do this. All right, so I've got 3 students over here on the left that haven't picked a partner. Dutch, Eric, and Alex, are you guys present? Is Dutch, or I'm sorry, I said Dutch. Duncan, Eric, and Alexander. That's what I get for not having my glasses on. Okay, Alex, you're with Eric. Well, Alex, you need to put yourself in there. Okay. Do you know how, Alex, to put yourself in with Eric? Well, Eric, you and Alex both need to go and pick one of these groups. So here, I'll do it. Eric, are you there? Is Eric here? Okay, I'm going to go ahead and just based off what you said, I'm going to go ahead and do it. So you guys are group 6. Okay. How about Duncan? Duncan, is Duncan present? Okay, so here's kind of what, let me have a look here. Let's see, give me just a second, guys. I'm going to stop sharing. Okay, yeah, he actually, okay, so Duncan hasn't been here since day one. All right, so refresh. Okay, so it looks like we have, let's see here, wait a minute, we've got, so Anthony and Benjamin, that's it. So which one of you was it that wanted to work by yourself?
Me, Ben.
Okay, Ben, unfortunately, you're going to have to work with Anthony.
Okay.
Okay, I mean, it's because I don't want to leave Anthony up the
That's
creek
fine.
without paddle. Okay, so I'm going to Anthony, I'm going to bring you down into Ben's group.
All right.
Okay?
All right.
Yeah, Duncan's not been here since the first week of class.
I mean,
so-
I don't mind doing like member one on my own or something along those lines if he wants to work by himself.
well, let's do this. I'll say that after you gotten into it, because I don't want to have any problems come demo day.
All right.
Yeah, because then it makes it, okay, how do you split it? And it's just not, it's really better if you guys work together on this. Now, folks, also, RASM 4 is a full blown out gnarly beast where you're going to do linked list in assembly. Trust me, you want to have a partner that you've kind of worked with already. You do not want to try to tackle RASM 4 by yourself unless you're just a glutton for punishment. Okay. Now I say that to kind of scare you, but it's really not that bad, but it's a lot of work. Okay. All right. So we have that set up now. And let's jump to the actual. Let me bring this up here too. Let me bring up this Linux ARM syscall. Actually, looks like I already have that. So let's just remove this whole thing. Okay, so the very first thing that we need, guys, is a driver. And that driver is going to ask the user to enter these three strings. So folks, these three strings have to be gotten from the
You're not sharing your screen, by the way.
oh shoot. All right. Thank you. So these first three strings, guys, you're going to read them in from the user. Now, I'm telling you arbitrarily that just because these are the strings we're using to grade it by, doesn't mean that you get to fudge things. You don't know how large these strings can be. They could be as large as, what do we say, 256 or 512? What does anybody recall? Let's see here. That's this is the full list, isn't it? Okay. Yeah, so these three strings class can be as large. Let's just say 256 bytes. Make it, if you want. I'm probably going to make mine 512 because I know that in RASM 4, that's what the limit's going to be. And what I want to do is I want to make my RASM 3 to where I don't have to change it as much, right? I want to use it as a base for RASM 4. So RASM 4 is a menu-based system. Okay. This one is just straight up prompts. So let's see. Let's go ahead and get. Let me get into here. Not sure where that thin client drives are coming from, though. But anyways, doesn't matter. And let's see, what was the last thing I worked on in here? Looks like November the October 27th. Source code P quiz. Oh yeah, Kent. I got them online. Guys, give me just a second, please. Hey guys, sorry about that. Had somebody needed some help with something. All right. So here we have, let's see here. All right. So folks, if you're already way ahead of me on this, then just, kind of chime in or peek in every once in a while. Go ahead and use this time to start your work.
I do have a question though, Professor.
Yes.
You had said that the strings should be like at least 256 bytes, correct?
Let me
Okay.
Let me explain, or let me better clarify. The buffer, your keyboard buffer for reading strings into your program should be 256 bytes.
Okay, that answers my question perfectly. Thank you.
Thank you. Thank you. I have a bad tendency of, because this is probably the 8th semester for me to have this particular RASM problem. And I think everybody has also had it 8 semesters. And I forget that you guys, this is new to you. So yes. So remember guys, a keyboard buffer. Now, nowadays the keyboards, well, they might still make keyboards that are really, really cheap that have a buffer in them. But keyboards now, they actually have memory in them. And you can sit there and, hold that A key down forever. Right now, this one here on the Pi, I'm just curious. If I hold down the A key on the Pi, now back in the 80s, and even 90s when I was in college, you could, I think 256 characters was as much as the Windows DOS would allow you to type. And then it would have, it wouldn't let you, it give you a ding, 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 ding if you try to go more than 256. That buffer was full. Right now, this guy is just chugging up memory, okay? Even on this Pi. Now, I don't know how long I could go like this, but I could go for a while, okay? Okay, command not found. Now, our simple interface, our simple user interface, we're just going to put, 256 or 512. And I would always encourage you to make it a power of 2. It just seems natural to make it instead of like 255. Well, why 255? Okay, so that's just my recommendation. And what you do is you read all of your get strings go into the buffer. Okay, so for this first string that we're going to do, yeah, that's what I'm going to type in. But when that comes in, then it's in the buffer. But then what I'm going to do is I'm going to see, okay, how large is that string in the buffer now? Remember, I put a get string puts a null at the end of it. I can now then count, okay, what's the string length of the buffer? Well, ever how big cat in a hat is, right? With a null, minus the null, actually, right? Because string length does not count the null. So if I do the string length on the buffer, and then I add 1 to it, that lets me know how much to malloc for S1. Okay, so I'll show you what I mean. It may take me a few minutes. Okay. All right, so what I'm going to have is I'm going to have a couple of prompts here. Let's see. Let me just kind of get this stuff lined up for it. Well, I was hoping I had that. I guess. All right, you guys may have to help me out on the malloc piece here. I think I can do it by memory. We'll do it. All right, so we're going to have a pointer, string 1 pointer, basically, right? That's a word. Basically, that's in essence making that a null pointer. I'm going to have string 2 pointer to null. I'm going to have string 3 pointer. That's a null. And I'm also going to have some messages in here, right? I'm going to have some prompt message, string message 1. I'm just playing around. Actually, it wouldn't be 512, would it? It'd be 511 characters max. Why? Because I need to have saved room for that null. Again, you don't have to word it like this. You can just say S1, you know. All right, so we'll give it a, there's that one. Man, if I was in, see, I don't remember. Let's see if I can do the shift in control. Let's see here. So to cut is control K. Then to paste, control U, enter, control U, enter, control U. Okay. That just gives me something to, to go out against. And let's just say that you know, we'll put a character in here. Character carriage return CR. What is that? That's a ASCII. Was it 10 or 13? I always get it backwards. I think it's 10. And that should be, let's see here, at least for the very beginnings. Now, my very first one, I'm going to say, well, here, there's this one. So I'm going to want to put a, you know, a label for each one of these. So maybe I just call this see here, string problem 1. Just something to give me the output that I want. All right, then I think that's going to be enough. Should have to refer to that for now. And then let's see. 511. All right, we don't need any of this anymore. Start text. And let's just go ahead and move into what? Register X0, the address of prompt 1, or string message 1, maybe string prompt 1, whatever you want to call it. And then we're going to do a branch and link to put string. And then we're going to move into X0, the address of my keyboard buffer, which I don't have. Now the keyboard buffer, there's a couple of different ways you can do this. Now I tell you what I like. I'm going to put that keyboard buffer at the bottom. Why? Because if I need to go through GDB and look at stuff, I don't want to have to be jumping around at 512 bytes of keyboard buffer. So, I'm just going to call it keyboard buff. And let's see, we can do a dot skip for 512 bytes. And again, this is my keyboard buffer. So we're going to put keyboard buffer in here. And then I'm going to branch and link to get string. Okay. Once I come back from get string, I'm then going to, let's see, well, what does AAPCS say about the X0 register? This will help us for your quiz. All right, so AAPCS says when it comes to preserving, callee, say a register whose value must be preserved over a function call if the function being called, the callee, needs to use the register, then it's responsible for saving and storing the old value. Okay. So here we are, obligations on the called routine to preserve the program state of the caller across the call. So the AAPCS 64 defines how subroutines can be separately written, separately compiled, and separately assembled to work together. It describes a contract between a calling routine and a called routine, or between a routine and its execution environment that defines the following. Okay. So obligations on all routines to preserve certain global invariants. Okay, so let's see more specifically. A subroutine invocation must preserve the contents of these registers. Well, guess what? X0 is not one of them. In all variants of the procedure call standard, registers have special roles. Okay. All right, so I have no expectations then coming back from getString unless getString says it's going to, that it does preserve register 0. And let's see what getString is supposed to do. Let's go back to our somewhat outdated now Professor B's functions, but getString still functions the same. It says all registers are preserved. Well, that should be AAPCS registers. Okay, so let's go to my getString, my source code, and let's see what we did. Well, before I do, I'm going to go ahead and finish this line of code. So let's say that if X0 has been preserved, then I can go ahead and do a branch and link to str ing length, and I'm sure I've got that spelled wrong. Okay, str length, maybe with a capital L. All right, we'll have a look and see. So if I go to my source directories, and if I do a, just do a descriptor of cat, X0 actually returns the number of bytes read. Ooh, in a way, I get a 2-for-1, don't I? Is that the case? We'll find out. That actually would save me from having to call string length, wouldn't it? All right. Well, let's so in this case, I don't need to do this. I already have that value. Okay. All right, and then when I'm done, of course, let's see, I don't have the, let's see here, what are we doing? We're just going to print that number, right? And that number needs to be in decimal format. I currently do not have, so you're going to have to call a branch and link to, what was it? Integer 64 to ASCII. I believe that's the function that we have. Okay, now I currently don't have that function, so I'm going to have to comment this out for now. And then when we're done, you would move into X0, the address of the SZ problem 1A.
I think we should be using LDR instead of move.
LDR, thank you. Yes, you are right. LDR. That would definitely cause the problem as soon as I could try to assemble it. Thank you.
We have another one on 29.
I'm half blind right now, guys. Okay, all these letters are fuzzy. LDR, and then we're going to branch and link to put string. Now, once we come back from this, you're then, well, because we have to, it's kind of a shell game here. You see, I can't shortcut. I'm actually going to have to call the string length on that function, because x0 is going to get overwritten the moment that I post out this response. Okay. So then I actually am going to have to call a, you know, I thought I was going to get away with one. What was it? We need to get the string length of, well, a couple of things need to happen here. I'm not ready to display the answer yet. Okay, I can't do this yet, what I'm doing here. This part here is going to display the answer for problem 1A, right? Not ready. Okay. What I need to do is I need to branch and link to malloc. But before I can branch, so how many bytes do I need? Well, if I typed in, let's say I typed in the word cat, C-A-T, enter. A 3 is going to be in register 0 or X0 right now. I need 4 bytes, not 3. So I'm going to have to add to X0 a 1. Okay. And this will, what this is going to do is this will give me enough space for the null. For the C string null, right? Is what I'm doing. Then what we'll do is we need to branch and link to malloc. When we come back, then we need to, X0 is going to have the address of where it is that malloc gave me those 4, 5, 20 bytes, whatever. Okay, I need to store that address into my pointer. String 1 pointer needs to get that address. Now, my keyboard buffer still has the data, but before I can copy it into my malloc area, I got to get the memory first. So here what we're doing is we are going to malloc enough memory to copy keyboard buffer, keybuff, into string 1. Into S1. Okay. Okay, so I've malloced it. Now what I need to do is X0 is actually holding that value. So what I want to do is I want to load, say into maybe X1, the address of SZ pointer 1. Okay. And then we should be able to just do what? A move? No. Can't move. We're going to have to store. So we're going to do an we're going to do an str. Okay, and we're going to store the contents of what? X0 into the address pointed to by X1. Now, if I'm done, if everything is if everything is good to go, then, that pointer will point to that address. Now, here's another thing that you might want to do, okay? Right now, I'm just going straight blindly as though I don't have any of these other string functions. But what I'm about to do is to copy. So now I'm about to copy from the keyboard buffer into S1, right? Into the, the dynamic RAM. Now, it turns out, do we not have a string copy function? That's one of those that needs to be built. I believe we do. Okay. Now, in essence, even though I'm kind of hard coding this string copy right now, what I'm going to end up doing is I'm actually going to build this eventually. And all this hard coding I'm doing right now to copy the string out of RAM, out of the keyboard buffer, and into its newly allocated memory, that all should be done inside this string copy function that I haven't built. You see? So in essence, everything from here down could be replaced simply by me writing the code to do a branch and link to, because why would I want to do the work twice? Copy. By the way, that should be string underscore length, right? There it is. So this, everything that I'm doing in here actually should be done in here. Branch and link to string copy. Now, what's the prerequisites? Okay. What's the prerequisites? What is it that string copy is supposed to do? This method accepts a string to copy. Okay. It allocates dynamically enough storage to hold a copy of the new characters. It copies the characters and returns the address of that newly created string. Okay. You will need to call the alloc, or that should be malloc method. The malloc method, the UML for which I have written, which is below, I've written this method. You only have to, okay. Now this is a, this sentence here is x86 stuff. We don't, you will need to call the malloc method. And I'm just going to leave it like, okay. So let's go back and think about it now. This method requires 2 strings. Okay. If we go down our parameter list, okay, you've got an X0. Now, I don't give you these details, but you can do it yourself. You can figure it out, but what makes sense. But to me, what makes sense on this function would be for, if X0 is what? X0 should be what? The source. And X1 can be the destination string. You can flip it, but as long as you guys, let's see here. Let's see if there's any more details to it. Yeah, string 1. Okay, let's go to the short list and see what we got there. String copy. Okay, looks like string copy was not on that Java. So then we'll use the C++ version for this. If you want to flip it the other way, that's up to you. Just you and your partner have to agree on it because you guys are going to be using these, and you guys are going to be using these in RASM 4. So I would suggest that we all use the same because you might end up switching partners. 3A is 3B. Let's see, textbooks. No, wait a minute. I need 1B. What am I doing? 1B textbooks. Let's look here. Okay, so string copy copies string 2 into the string variable S1. Now, S1 will be the new malloc string. S2 is the source. Okay, so we want to so X0 will have the pointer. So in essence, this actually could be a null. String copy could just be a could just return 0 actually. Shouldn't need to return anything. If you want to make it to where it returns the address, folks, again, you get to decide the internals of this. Okay, but the way that string copy normally works is it's str cpy s1 comma s2. Okay, this is the C++ version. Java, the Java version for this does not exist. They have something similar, but it's not exactly the same. That's why you won't. It's kind of hard to find.
On the RASM 3 assignment page, it says to return the address
I know what it is,
X0.
yes.
Yeah, okay.
That's what I'm telling you. You can do either one. You can do either one. But now that I'm building this, I'm re-looking at this again. I'm thinking, to me, it would make more sense because it would be less work on the driver if I want to make string copy. And guys, you can kind of customize this yourself. Okay. In my version that I'm going to do, I don't think I'm going to do that. I think it's more efficient to just send it the pointer variable, right? Again, I'll leave it to you. If you passed, if you call string copy and you passed it pointer 1, and you passed it string pointer 2. And if when it comes back, if it does it for me, if string copy will store the address into my pointer variable up here, that would be pretty sweet. Otherwise, I have to manually do it myself every single time I call string copy. So I would argue that would be a better version of it. But again, if you guys want to, go off of that, I don't want to change it, right? Obviously, because you guys have already been working on it. But I'm thinking that would be a much better version of string copy, as opposed, and all the messy stuff is dealt with inside string copy. So basically what I would do is I would load into X0 my source, which would be keyboard buffer. Okay. And then I'd load into X1, the destination. Well, wait a minute, did we get that backwards? I think I had that backwards. Let's go back. S2 into S1. All right, so that would be destination source. So the destination here would be SZ pointer 1. And the keyboard buffer would be the source. And all the messiness for this is dealt inside the string copy. I don't have to worry about any of that. Now then, so this malloking business, see, I don't have to do any of, I mean, this would actually be inside my code for string copy. So I'm just going to highlight this for now. So when we come back from calling string copy, then string pointer 1 would have the contents. Then what we can do is we can display the partial answer. We're going to put string my problem 1A s1.string length is, and then we would have to load into X0 string length, not string length, hold on. SZ pointer 1, then do a branch and link to string length. When we come back from string length, X0 will have that contents, those contents. And then I can branch and link to my integer 64 to ASCII function that I haven't written yet. You see. And what's that going to do? Well, that's going to come back with register 0 with that value. I'm sorry. Integer 64 to ASCII has to be passed a string large enough let's see here, let's go back and look. R0 contains the value to be converted to ASCII, okay, which would be X0 in our case, and then R1 must point to an address large enough to hold the converted value. All right, so now I need another variable. So X1 or X0 already has the value from the string length. So then we can just LDR into X1 the address of what we're going to call this length len, and that's going to be an ilen integer ilen, So island will be island here. And that can just be a word. I mean, truth is I could probably make it a lot smaller. I can make it probably a single byte, but we'll make it a word. And we'll initialize that to 0. Sorry, that's the string. That's supposed to be a byte. So how many ASCII? So let's say 5, 12, 3, 4, 4. I think 4 would be enough. I mean, make it 4 digits, more than 1,000. So yeah, we'll go with 4. That'll hold enough characters to include the null at the end. So technically, this thing should work with up to 999 characters, even though my buffer will only hold 511. Load X1 and okay. So this, when it come back, then I length should have that. And then if I want to actually put the value, I'm going to have to LDR into X0 again, this time with the value of I length, and then call put string, put out my answer, and then LDR X0 with my C carriage return, and then do a branching link to put CH. And that series, guys, right there, this should get me my very first result. Now, there's a lot going on there. Just to get that very first one pieced out, okay? Now, you can do, to me, what probably might make even better sense would be, you know, there's nothing saying that I can't do all 3 string all 3 get strings right away. I mean, it kind of just depends. It doesn't matter. Let me plug in my Wacom tablet here if I can get it to reach. Give me a second, guys. All right. So you could input your, your 3. You can do your input times 3, which would include you could do this guy here 3 times in a row if you wanted. Go ahead and get the data stored in malloc using a string copy 3 times. You could, or you can do them one at a time. Get your input, do your copying, get your string length and print the value out. Or you could get all 3, you could compute, well, that would require you to have 3 of these, right? 1 for each one, which you can argue one way or the other. Doesn't matter. Okay. But the key, guys, here is that you're able, right off the bat, I'm using 1, 2, 3. Now, see here. Now, string copy itself is going to have to call string length in order to know how far to go. Or maybe string copy just blindly copies. But no, it's got to be able to count. It's got to be able to know how many bytes, right? So this is, like I said, this problem is the driver itself. You and your partner are going to have to be very, very working, very close together so that you know how these functions are supposed to work. Okay, that's why you can't just do these in a bubble. Right now, and then of course you repeat the process for this problem, and then this problem, and then this problem here. So this is exactly what you're seeing here, class, is exactly what the output should be. Assuming I don't switch the input on you, right? Okay. I'm always cautious of the students, and I've had them do it before. They've tried it, where people just hard code the answers. Okay, but we don't want to do that.
Do you want us to literally put string 1.length equals to true, or can we put a different message?
I would like for you to print this exactly the way that it is here.
Okay.
So that on demo day, we can fly through those things and, have you out of there pretty quick. Yeah. All right, I see there's some chat. I haven't looked in a while. Let's see what's in here. What should the string copy do if the target string is too short? Very good question. What should it do? Well, what does string copy do in C++? I don't, off the top of my head, I don't know. What does string copy do in C++ if the source is not, the destination is not large enough? By the way, but first of all, let me correct you. Wait a minute. String copy is going to figure out how large it should be to begin with. You see, that's the thing. The target or the destination string, see, string copy is just getting 2 pointer variables, guys. String copy will figure out how much to malloc on the source data. So, Alex, see, you can't, that can't happen, you see. String copy, no worries. No worries, it's easy. But that's a good question that I want everybody else to see, is that the string copy is only going to get 2 pointers. And then the second pointer, which is my original data, right? It's going to be left untouched. It's going to call string length to find out how large that is. It's going to add 1 so that when it goes to malloc, it has enough to make another completely new string. And my pointer, my string 1 pointer is going to be updated. Okay. All right, let's see what else we got.
I also have a question.
Yes.
The way that I've been programming my driver thus far has been taking inputs to run the specific functions. Should I take that out and just hard code the specific values you want the examples to have?
No, completely the opposite.
Okay.
The way that I was doing here sounds like the way you've been doing it. I want you to, you're going to call getString to get the values. See, remember getString. What getString is going to do is you're going to tell getString, right? You're going to get 3 values from the keyboard, right? Each time getString is going to store whatever the user typed into my keyboard buffer, and it's going to overwrite that every time. That buffer is going to get overwritten over and over and over and over again. It's used as like a scratch pad, right? And so, the first time I go to read in string 1, getString will store what I typed into the keyboard buffer, and then I've got to call string copy. I got to call string copy to get in there into that keyboard buffer. Now it doesn't mess with keyboard buffer, but it's going to start at the very first byte of keyboard buffer and read until it finds a null.
I meant
Okay.
more specifically in relation to things like for when you're trying to show string index of 1, do you want me to hard code in the value of G?
Oh, let's see. Let me see what you're talking about. I guess I misunderstood you. So which one here? This one?
No, not that one. It is number 13. Like the value, the character value G. Do you want me to hard code that in or
Yeah,
get user
yeah.
input? Okay.
Yeah, hard code that one. Now what would happen here? String 2. Yeah, folks, I'm not changing this. I'm not going to change the input on you. But yeah, that one. Yeah, so these are all hard coded. Okay, so it sounds like you guys are some of you are almost done. Is anybody completely done with this already? With this assignment? Okay. This assignment class is, like I said, you're going to be using a lot of these functions. Not a lot, maybe 7 or 8 for RASM4. Okay, RASM4, you're going to be making a text editor. You're going to be making like your own cryptic notepad executable assignment that is more, it's very, very yabba dabba do though. It's very yabba dabba do. Okay. And you're going to need to be able to use these. Okay. All right, guys, let's do this. Right now it is what? It's almost 1. Let's see here, right? What time is it? Clocks. I got different time zones. Okay, so yeah, it's 12:39. And let's see, this class goes to when? Was it 1:50? How long does this class go till? It's 1:50, right?
Yeah, it's 150.
Okay. All right, so we've got about an hour. So I want to take about a 10-minute break, and I'm going to come back and I'm actually going to write some code. I'm thinking about going ahead and I'm going to go ahead and build my string copy function. Okay. Now I'm going to do this on my own. I'm not going to show you my string copy function, the guts of it, but when I get it working, I'll come back and then we'll, you know, if you guys want to see me demo the string copy function, I can do that. But I want you to figure these out by yourself. You guys should be well enough along. I mean, you guys were probably one of the better groups. I mean, we're a smaller group this semester than before, but you guys seem to have picked this up pretty good, right? So let's take a 10-minute break. I'm gonna go grab something to eat, and then I'll come back and I'm gonna code it in the blind though. I'm not gonna let you guys copy me, right? I want, you know, no pun intended. You can't copy my string copy. Okay. All right, so folks, give me a thumbs up. How many of you are feeling pretty good, at least for the these very first few string functions? You guys give me some kind of indicator of how you're doing in this class, as far as where you are. You may not understand everything, but you should be, you know, hopefully feeling better about it a lot. Okay, folks, give me about 10 minutes. I'll come back. And the one nice thing, guys, is that by me making that output the way it is on the assignment, there's no surprises, none. That output should be exactly what you're seeing on that screen. If you find your interpretation of these Java functions is different, you got to let me know like now, right? Not the day of, okay? Because it's too late. It's too late. And this has already gone through a couple of semesters. Okay, so I think there's one of those functions that's a little tricky, but that's why I gave you the website, the Java website. And you can always write Java code to test that the answer is what it should be. Okay. All right, folks, I'll be back in about 10. Take care.
Uh,
Hey, I think you left your mic on accident.
My bad.
No worries.
Okay, guys, as I'm sitting here working on this, I keep trying to remind myself, I need to go ahead and take attendance. Let's go ahead and do that. When I call off your name, just type that you're here in the chat bar. As soon as I get things situated here. Okay, guys, Jared, Daniel, and Chase. Okay, good. Anthony, Angela, and Jonathan. Is Angela here? Angela Hahn? Angela? Okay, there she is. Okay, Duncan, Brandon, and Eric. Brandon, Duncan, and Eric. Duncan. Oh, that's right, he's not been. Okay, and Eric. Eric's not here either. Gregory, Alex, Alexander Canstel, and Yassine. Yeah, hopefully Eric's fine. Let's see, Gregory, Alex, Yassine. Okay, Alex, okay, got you. Okay, Jordan and Benjamin. And Johnny, finally Johnny. Okay, so absences, I've got Duncan and Eric. Okay, guys, that's going to do it for me today. I mean, I'm going to stay online. I'm sitting here coding out my I'm coding out my string copy. I will show you some of it before you guys kind of sign off. So what I'm currently doing is I am going to allocate. I have to find out the size of my source string, and then I'm going to add one for the null. And I'm actually storing this information on the stack because malloc is going to wreck things for us. Malloc does not preserve anything. And since x0 and x1, those are my primary arguments, I need to save those. And I probably need to push x1 as well. Right, so I'm going through this part here, debugging this before I haven't run it yet. But the idea is you find the length of the string, you malloc, and then you store the address of the new memory onto your destination variable, which is S1 in my case. And then I want to create a loop that goes through and copies byte by byte from the destination, from the source document into the destination document. Okay, and I just have to go through the, I have to go through the details of that, and maybe 10 lines, 15 lines of code before it's said and done, other than the AEPCS stuff. Okay. Yeah, so why not just move them to preserve? You could, but see, you could, absolutely. If you wanted to move them, well, but wait a minute, no. See, remember, malloc is not AAPCS compliant. So nothing's safe with malloc. Yeah, nothing's safe. You'll find out. Now, maybe they've upgraded malloc since the 32-bit version. Maybe they have. And in that case, yeah, it's not compliant. It's not, malloc is not, I mean, it's part of the C library, right? The C++ library. It's not AAPCS compliant. Okay, so anyways, just be cautious. And it might turn out that the 64-bit version, they've changed things. But I know in the 32-bit version of malloc, you think something's in register 1 when you come back, and it's not there anymore. Okay, so make sure that you put that in your little brain cap there. And so I'm just going to use my stack for what it's meant for. I could use it to save data. Then I'm going to pop it back off the stack at an appropriate time. But it's kind of messed up a little bit here. I really need to go home, or not go home, but go, we'll go to the house here and get my glasses. So it's kind of hard for me to see this, but basically that's the idea, is that you just loop through one byte at a time after you've mallocked, but the act of calling malloc, just remember, it's going to mess up with your registers. Okay, not all of them, but some of them. Okay, guys, that's going to be it. I'm going to be here. I'm not going anywhere, but I'm not going to be, passing any more information. So I'm going to stop sharing, and I'll see you guys next class. And good luck on your RASM 3.